Hello, this is Professor White. Today we will talk about complex numbers. Let's get started. Alright, we will start with imaginary numbers. We'll just define it. So this is intermediate algebra level. Just don't worry about it. We are going to define I as square root of -1. Remember up until now, we were saying, oh, don't take square roots of negative numbers, but now we will. So if I is square root of -1, that means I squared has to be -1. So please remember either that, or this, or both. It doesn't matter. All right? But you're going to have to remember that. Okay, so if you remember that, look how you can do this. So square root of -4, the negative portion is going to give you the I, and square root of 4 will give you the 2. All right, let's do this one. Square root of -4, and then there's a negative in front of it. So let's take care of that first. Square root of -4 is 2i, and then you have a negative in front of it. All right, but don't mix that one up with a negative of square root of 4. With square root of 4, that's 2, and then there's a negative in front of it. All right, what happens when non-perfect square roots? That means, you know, it's not a perfect square, and so you cannot do this. So you can write this as -2 times 4. So I know that 4 is going to come out as 2, and this negative is going to come out as I. And then what do you have in the middle that's left by himself is rad 2. If you kind of paid attention to my radical notation, I just put a little notch in there so that that's the end of my square root. Let's do this one. Again, everything is the same, but there's a negative in front of it. So I can write that the same way, 2 rad 2i. And guess what? There is a negative in front of it. Okay, don't mix that one up with negative rad 8, which is, rad 8 is 2 times 4. And that comes out as 2 rad 2. And guess what? There's a negative and negative. So these are kind of important things. So let me kind of move this up. Here you go. 2i, -2i, -2. Non-perfect ones, you just leave them as radicals. Pay attention to the negatives. And, you know, there's no negative here, so there's no I. Very good. Okay. Be careful. This rule, the product rule, only applies to non-negative numbers. If you have negative numbers, so in other words, you cannot do this. Watch. Don't. So you can say, okay, you cannot say -4 times -9 equals 4 times 9, 36, negative, negative, positive, 6. Don't ever do that. You cannot do that. All right, so what can you do? Square root of -4 is 2i. Square root of -9 is 3i. 2 times 3 is 6. I times I, what was that? I squared. I squared is negative. So you have -6 in there. Okay, so pay attention to that. All right. Powers of I, how does that work? I is I. Now I'm going to multiply everything by I each time. So this is going to obtain with I times I. So it's going to be I times I is I squared, so that's -1. Multiply by I, that's -I. Multiply by I, that's -I squared, which is 1. So you have I, -1, -I, 1. Now let's go to the next step. Multiply that by I, you get I. Multiply this by I, you get -1. Multiply this by I, you get -I. Multiply this by I, you get 1. Oh, all of a sudden I see a pattern. I, -1, -I1. I, -1, -I1. Okay, what does that tell me? So I'm going to actually make a little, when you see a pattern, this is what I do. This is the result. So these are the indexes. So this is 1, 2, 3, 4, 5, 6, 7, 8. So when it's 1, it's I. Okay, when it's 2, it's negative 1. When it's 3, negative I. When it's 4, it's 1. Then you go, when it's 5, it's I. When it's 6, it's negative 1. When it's 7, it's negative I. When it's 8, 1. And now you can continue. When it's 9, it's I. Now, you kind of look. What does 5 and 9 have in common? What they have in common is that when you divide them by 4, you get a remainder of 1. So, what does that mean? So, when you have a remainder of 1, the answer is going to be I. When you get a remainder of 2, like in this case, the answer is negative 1. When you get a remainder of 3, the answer is 1. And when you get no, okay, well, here we go. When you get no remainder, the answer, oops, I did it. I, negative 1, negative I, and then 1. Okay, so when you have a remainder of 1, it's I. Remainder of 2 is negative 1. Remainder of 3 is negative I. No remainder is 1. So I can actually do my results with that. So let's look at 24. Let's go and divide 24 by 4. Guess what? I get no remainder. What is no remainder? That is 1. How about 31? 4 times 7 is 28. That's a remainder of 3. Remainder of 3 is negative I. Okay, how about 45? 45 divided by 4. 4 divided by 4 is 1. 4 divided by 4 is 1. And then bring the 5. 1 times 4 is 4. That's a remainder of 1. Remainder of 1 is I. So, all you have to remember is kind of make a little table here. And now look at your remainders. And then kind of find out what that gives you. And you can go as high as you want in terms of indices. And, you know, just divide by 4 and look at your remainder. And that'll give you the answer. Okay. Now, what's a complex number? A complex number is a number that has a real part and an imaginary part. That's all. So let's look at some complex numbers. 3 plus 4i is 1. You can have a minus instead of plus. 2 minus 3.1i. And usually you put the real number first and then the imaginary part. Real, imaginary part. These are all complex numbers. Okay, well, how do I add and subtract complex numbers? I just do them the way, just treat I as if it is an x. Add the real parts, add the imaginary parts. What do I get? 2 plus 4, that's 6. 3 minus 2, that's 1. And you have an I. Well, you don't have to write the 1. 6 plus I. Well, I can do the subtraction the same way. I would just go and write it without the parentheses first. Work that negative in. What do you get? 2 minus 4, that's negative 2. 3 plus 2 is 5. I. Alright, so addition subtraction is not all that bad. Well, how do I multiply complex numbers? Let's multiply them with a real number. You just have to FOIL it the way you FOIL everything else. 2 times 3, that's 6. 2 times 4, that's 8. And you have an I. Well, when that monomial is an imaginary number, what do? 2 times 3, that's 6. And there is an I in there. 2 times 4, that's 8. I times I is I squared. And you have a negative. Now I need to go one more step. 6i. I know I squared is negative 1, so negative negative is a positive. And usually I write the real part first. 8 plus 6i. Okay. Now what happens when you multiply a complex number with a complex number? You FOIL it the way you would FOIL binomials. 2 times 3, 6. 2 times 4, 8. 3 times 3, 9. Here you go, pay attention. 3 times 4, 12. I squared. And now you have a negative. Now let's rewrite. 6. Negative 8 plus 9, that's 1. So I got rid of this, this, and that. What is that? I squared is negative, negative, that's positive. That's 12. I write the real part first. 12 plus 6, 18, plus I. So I did the multiplication. Well, let's do more multiplication. Okay, this is like a plus b squared. How do you do that? A squared, b squared, 2ab. So let's do that fast. A squared, that's 4. B squared, that's I squared. And the middle term, 2 times AB. 2 times 2I. And then another one, 4I. Okay. Now what do I do? This one is negative 1. 4 minus 1, that's 3, plus 4I. So I ended up with a complex number. Okay, well, how about this one? How do you do this guy? Just like binomial multiplication, that's a squared minus 2ab plus b squared. All right? So a squared is 4. B squared is I squared. And the middle term is 4I. All right? So I squared, just like before, is negative 1. 4 minus 1, that's 3. But this time you have minus 4I. Very good. Let's do here. 2 plus I, 2 minus I. How does that work? This is like a plus b times a minus b. What does that give you? A squared minus b squared. So that is 4 minus I squared. What is I squared? Negative 1. 4 minus negative 1. Oh, look what you got. 5. All right, when I did a plus b, a minus b, I'm going to remember that. I got rid of the imaginary part. Actually, you will see that in division. These are conjugates of each other, and that's a great way of getting rid of the I. So let's do this one. I'm going to do this part first. 1 plus I, 1 minus I. That's going to be 1 minus I squared, which happens to be 1 plus 1, which happens to be 2. Now I had a 3i, and I'm supposed to multiply by 2. What do I get? 6i. So you can actually expand on this whole concept of multiplication. All right. Let's start dividing. Let's divide a complex number by a real number. You can split these guys and write the result 1. 6 divided by 2, that's 3, and you have an I. All right. What happens when you're dividing by an imaginary number? You split it the same way. 2 over 2i plus 6i over 2i. Let's do a couple of things. 2's go, and this one goes, and this one goes, and you're going to end up with a 3. And this one, 2's will go, you'll end up with 1 over I plus 3. Well, that doesn't look like it is in the standard form. This is what you're going to do. let's go and deal with this separately. You have 1 over I plus 3. Now what I'm going to do, I don't want I in the denominator, so I'm going to go and multiply top and bottom by I. You're going to get I over I squared. Now, what is I squared? That's negative I over negative 1 plus 3. Write the real part first. 3 minus I. Do you see that? So, never leave i's in the denominators. You have to get rid of them by multiplying by I, for example. Okay, what happens when you're dividing 1 by 1 plus I? I cannot really do that, so this is what you do. You do a trick. When you have a complex number in the denominator, what you do is you multiply the top and the bottom by its conjugate. Alright, now what does the bottom give you? This one is a squared minus b squared, which is 1 minus I squared, which is 1 minus minus 1, which is 2. So you have a 2. Now what else do? You just FOIL the top. 2 times 1 is 2. This is I. 2I. And this one is plus 6I. And this one is minus 6I squared. So what does that give you? Negative 2 plus 6, so that's plus 4. And negative 6I squared is plus 6. That gives you 6 plus 2, 8. Plus 4. And now you can divide. You get 8 divided by 2, that's 4. 4 divided by 2, that's 2. And this one is in the standard form. Okay, now what do you do when you are dividing by 1 minus I instead of 1 plus I? You again multiply top and bottom by the conjugate, which happens to be 1 plus I. What do you have on top? 2 plus 6I, 1 plus I. And the denominator is just like I did, 2. Let's FOIL the top. 2, 2I, 6I, plus 6I squared. 2, 6 plus 2, that's 8. And this one is minus 6. 2 minus 6 is minus 4. 8I over 2. Now divide. Negative 2 plus 4I. Alright? Very good. So, this is the end of the division of complex and imaginary numbers.